Yes, we are.
All right, well, thank you everyone who's on the line. We're here tonight for the public information meeting for the wastewater treatment plant major capital improvements project. My name is Ernie West. I'm the township engineer. With me tonight, that's going to be helping with the presentation and questions and answers. I've got Rick Kane, our utilities director, and I also have Gary Markstrom and Brent Bode from our engineering consultant, Tetra Tech. Dave Marquette is our township utility IT director. He'll have help us out with any technology issues we face with this this format. So with that, Dave, if you want to address any items about how to raise your hand or call to be called on, or any other Zoom issues.
Sure, certainly. In Zoom, you can raise your hand, and you can also use reactions down at the bottom part of your screen, either a thumbs up or a wave. It's actually a clapping emoji, but I can look for that while Ernie's giving his presentation to then flag him that you may have a question. And then if you could just, for those of you that might not have your first and last name addressed here in the meeting, to maybe rename yourself. So if you do interact, that those recording the minutes and stuff could accurately get your first and last name. That's it.
Thanks, Dave. So with that, just some rules for the discussion tonight. I'd like to make sure we conduct ourselves in a courteous and respectful manner. We ask that you keep yourself muted until you request to speak and are called on just by the presenter, just so that you don't have any background disruption to the presentation. When you get called on, we'd ask you just state your full name and address before making a comment or asking a question, so you know who we're speaking with. We'd try to, I don't know if it'll come into play, but if needed, we'll limit each speaker to 3 minutes, and we're not going to allow sharing of time with other speakers. We are going to record the meeting tonight and make it available on the township's website in case there's folks that weren't able to join us live for the discussion. In general, I'm okay with accepting questions as we go on. I like to keep it as informal as we can. However, I may reserve the right to defer a question response until the end, just so we don't get too far off track. So I do want to have plenty of time for answering questions, but I want to try to get through the material as quickly as we can. With that, let's get right into it. So the why of the project, what's the need? Why do we need to do a major capital improvement at the wastewater treatment plant? This is a photo on this slide dating to the original plant construction from 1965. If you're curious, it's kind of looking southeast towards Willow Highway, standing up on the hill. But this site's been a wastewater plant since 1965 and has had a couple iterations since. In order to determine, what kind of improvements were needed, and really get our heads wrapped around, what needs to happen at the wastewater plant to serve our residents for the next 30 years. We've taken several steps over the last 3 years or so, beginning in 2017 with some board direction to really dig into some of our infrastructure. And so that led us on a path of doing an evaluation, a full evaluation of the plant, beginning in the summer of 18. We wrapped that up last summer with a presentation to the board, presented some of our findings. And we'll get into what those were here in a minute. But then we started looking at, we started getting information from the Department of Environment, Great Lakes and Energy regarding some new permit limits that were going to be put into place on our next renewed permit that really drive some of what we're going to talk about tonight. So then through the fall of last year, we kind of reviewed some of our work by completing a peer review. We got a consultant involved to begin looking at our utility rate structure. And then in November, the board authorized a preparation of this SRF project plan. And this project plan is required by Eagle to obtain some funding for the project. And so it's really a comprehensive document that takes quite a while to put together. And so what we've got now is a draft, and we made that draft available in May, and rolled it out to the board and then the public. And so we're in this public information and comment period where we're going to make sure people know what's being talked about, what's being planned, and try to answer questions and receive input. So that's kind of where we're at. That's the steps in terms of how we got to where we're at today. So there's three primary drivers for the project that we learned during all the study and evaluation of the plant. The first being really the age of the facility. At 55 years ago was the first construction. The last major upgrade was 34 years ago. And with that, things wear out. And you can see this list of kind of equipment failures that we've been incurring almost every year since 2015. We've had at least one, if not multiple, equipment issues that our staff have had to overcome to maintain our operations. So things are wearing out. That's a primary driver. This is just in the way of history. This photo is from 1972. So this would be the first expansion and upgrade from the original construction. A second primary driver for the project is the tougher treatment standards that I mentioned. So these are intended to improve water quality in the Grand River. They have given us a timeline to get into design and construction and have a new treatment process constructed that will treat to a higher level by 2027. This is a new process the existing plant doesn't have, and it's going to consist of what we call tertiary treatment process. It's really a final filtration just prior to disinfection and putting the treated water into the Grand River. So it's going to further reduce any solids or pollutants in the treated water. And the goal of Eagle is really to improve the water quality, dissolved oxygen levels, lower sedimentation, solids levels. But it's like I said, it's a new process that we just currently don't have, and so that's going to be a major driver on what improvements we need to have out there. The third driver is capacity. We're currently around 80% of our design capacity on an average basis, but we currently see flows higher than our capacity during wetter weather. This chart is a little kind of a lot going on, but on the left are the different, down the left-hand side are the different processes on the plant. And then across the top are the different flow conditions that we have to be able to treat to. And everything in red shows that we have a condition that exceeds what the design capacity is. So you can see even in the 2019 conditions, we exceed our capacities quite often. And certainly when we start to look 30 years out, we're not going to have enough capacity to treat all the flow that comes at us. So with that, we want to, you know, if we're looking at doing a project, we want to make sure we're smart about it, and we, you know, build in some capacity for the future. And so what we've done is we've looked at the township land use. This map on the left, all the tan areas are already served by sewer, but all the parcels in red and in blue are within the service area that aren't served, that could develop. And so we've taken our best estimation of what might build in the 30-year period and what will probably build, but, you know, further out. So with that, we want to be able to provide capacity for continued growth, but with a modest expansion of treatment capacity. And later on, I'll show how we've actually put some of that off into a third future phase, which would really be dictated by when the flow capacity is needed. So capacity, additional treatment capacity is the third reason, the main driver for the project. These three make up the why we need to do something. As far as what proposed work there is, because the last treatment plant expansion was in '86 and almost all the equipment is from that era, unfortunately it's almost all wearing out at the same time. So really the entire plant needs to be some amount of work done to it. Within that, we reviewed lots of different alternatives. Four main ones that are listed here, and some of these are required by Eagle in terms of what we look at in preparation of our project plan, such as do nothing, which we don't feel is feasible, or a regional alternative, which we did look at and were found to be prohibitively expensive and overly complicated. But really, within the two main ones, A and B here on the screen, there were 7 or 8 variations among these. But we kind of boiled them down for this presentation to the two main, which is repairing and retrofitting the system. So trying to work with what we have to the greatest extent possible, adding onto it to increase capacity and adding the additional treatment system. Or B is reconstructing a modified system, kind of a lot of it off to the side, and not rehabilitating what we've got. And when we really dug into it, we found that reconstruction was found to be more cost effective, both to build and operate, and we're anticipating it's going to use 34% less energy as compared to trying to repair and retrofit the plant system the way it currently situated. So A and B are the two main alternatives, and we are recommending alternate B. So what does that look like? This graphic tries to illustrate that, kind of starting on the left-hand side. And when I say reconstruct, you know, that's because there's a large section of the process that gets reconstructed, but certainly we're not reconstructing every process out there. So there is some rehab, and I'm going to kind of work through those. Our solids handling systems will be rehabbed. Our primary electrical service will be rebuilt. Our digestion system will be rehabbed. Our raw sewer pumping will be rebuilt. And then up in this area of the site where we've got open space, this is where most of the new build will be. Aeration improvements, new final clarifiers, new tertiary treatment. So this would be the new process that I discussed. And then new UV disinfection. And then we also have a primary clarifier and grit removal improvements up here. There'll be a rehab and then a new laboratory control and operations building. So that's kind of a high level overview. There's a lot that goes into all those pieces, but that's kind of the overview of what we're looking at. The big thing is to remember we're really every process out there is going to be affected to some extent. Again, trying to set us up for a 30-year design life moving forward. By taking advantage of some of the open space out in this area, that allows us to helps us to keep the existing plant in service while we're constructing the new improvements. The other thing I'd point out on this slide is that you can tell all this work is within the existing fence line of the treatment plant. So we're not expanding outside of the plant footprint that's already maintained and mowed and within the fence line. And if we can certainly take questions later, and then there also is a lot more detail in terms of all these different improvements within the SRF plan itself. So one of the main reasons we chose the option we did, where we're building a lot of new structures, and when I mentioned the 34% energy savings, it's because this option allows gravity to do the work. This graphic here kind of shows a vertical view of the water flowing through the plant. This structure right here are these towers down here in this photo. This site has a large hill, and right now we pump water up to the top of the hill, and then it drops down through this structure in about 34 feet. And so when the water gets down to the bottom of that structure, it's down here right now. And you can see over here is the Grand River floodplain elevation. So it's not all that higher than that floodplain elevation. And we have to insert a new process into that. To try to do that at this lower level, we would have to basically repump the water up. And with that comes the cost of maintaining the pumps, the electrical cost, forever ongoing electrical cost to run those pumps. So by reconstructing several components, the aeration, final clarification, and the new process, up here on this hill, at a higher elevation, that allows us to let gravity work and carry that water through the plant without having to repump it. And that's where the majority of the savings come from for operational and electrical savings. So that's really what drives the selection of the chosen alternative. I mentioned the savings, the energy savings. These two, this is a comparison of basically the retrofit option versus the reconstruct option. And in several processes, we're able to eliminate electrical usage. And that's how we were able to save over 1 million kilowatt hours of electricity to the tune of a couple $100,000 a year. I'm sorry, $116,000 a year of annual energy savings. So that's how that's the beneficial impact of reconstructing that stuff, utilizing the kind of unique topography of our site with that large hill and really changing the hydraulic profile of how the water flows through the plant. So that's what we have in mind. How are we going to pay for it? What's it going to cost is always everyone wants to know. We've basically taken the project and broken it up into really 3 phases. Phase 1 and 2 are what's in this SRF plan. The SRF plan could only include work that we anticipated starting within a 5-year period. So phase 1 and 2 is really work that needs to happen based upon the condition of everything, and needing to expand our capacity, address the failing infrastructure, and address the new treatment standards. So phase 1 and 2, phase 1 I would describe as really our most pressing issues, and just trying to set it up for the addition of the tertiary treatment. The tertiary treatment comes in phase 2, and all the work in phase 1 needs to be done before we can get to that point. So it's a phased project. Phase 3, which doesn't show here, is really more flow driven. So as our development occurs, if we were to see it occur at a faster rate and the flows come up, we are able to add a tank here for this process or there, depending on where it's needed, and really implement those changes more when the flow dictates instead of up front. And we think that's a good way to handle not overbuilding up front and having to incur that cost, but letting the flow conditions dictate when we build those. So phase 1 and 2 are roughly $35 million a piece, with the breakdown between the different systems as we show here. Probably the other thing I would say is, this phasing, it does meet the 2027 deadline. And I would also note that these costs, we try to show full project costs so that we cover things like engineering and contingencies for unknown conditions. So we hope they're conservative, but obviously as we get into design, we'll start to clarify all of these different pieces that make up these totals. So how are we going to pay for it? That's what this process is about. The township has decided to apply for Clean Water State Revolving Fund, which is a program set up by the federal government and administered through the state, and it's used by most municipalities to fund these types of large wastewater projects. Basically, it's a loan, a low interest loan that would be repaid over a 20-year period, and that we have to be able to show that we have sufficient revenue from our sewer bills to pay for that debt payments, and that would be on top of our normal operating costs. So certainly to be able to pay that debt service on top of the operating costs we have, sewer rates are going to have to increase, and we're doing a very comprehensive study right now on those that will help guide the board through that setting of those rates. Right now we're around $27.50 a month for a typical residential sewer bill. And we track that, and that's in comparison to our neighbors in the region, and we're one of the lowest, if not the lowest rate in the region. So we have no debt on the books right now, so we're in a pretty good place to start from going into this project. We're looking at roughly an average of 6% increase over roughly a 6-year period to get where we need to be to fund the debt service at the end of phase 2, which is equate to about $10 a month, again, for the average residential monthly bill. But even at that rate, if you added $10 a month right now, we would still be competitive in the region to our neighbors. And this chart just shows, the analysis that we go through. And I just point out that it shows, it doesn't assume any new users. new growth, and it doesn't account for any type of grant dollars that we may be able to acquire from our green project program, which really, when I talk about the energy savings, that's one of the things they look for. If we can show a high level of energy efficiency, they have special funding available to help do some loan forgiveness. So we hope this is a pretty conservative analysis, and like I said, it will evolve as things move through the process. So project impacts, what are we expecting for impacts? So there's several categories that we look at and that the Eagle requires as we put this plan together. The first one being archaeological and historical resources. There are no known archaeological or historical resources in the area. There's a state historic preservation office review underway to confirm that. So we're awaiting that finding. But really it goes back, the work inside at the project will be inside the fenced area. It's already been constructed on 3 times since 1965, and it's been a wastewater plant since 1965. So we're not expecting any impacts to those resources. In terms of water and air quality, we look at water quality. Certainly we expect a beneficial impact on water quality from adding the tertiary treatment process, and that's a long-term moving forward impacts. So, you know, as the community is trended towards more river recreation with the canoe launches and whatnot that we've invested in, certainly we think that's a good thing. Short term, you know, any construction, earth disturbance can impact water quality if you don't take best practice measures with soil erosion and sedimentation control, and we'll utilize those best practices to prevent runoff from the site, which could impact water quality. Air quality, odor control system. The plant currently has an odor control system. The plan is to replace it with new equipment. This will continue to help mitigate odors from plant operations. And we're also changing process a little bit, getting rid of those tall trickling filters, which currently are some of the odor generators. So that'll be forefront in our design efforts to try to mitigate that through proper design. Dust control, we'll be cognizant of maintaining dust control during construction to make sure we're not having dust blowing off the site during construction. Natural settings and sensitive ecosystems. Again, with the work all occurring inside the fence area, we're not anticipating any impact on wetland, farmland, wild or scenic rivers. We did have a no effect on endangered species finding that we've already been received from U.S. Fish and Wildlife. There is some potential impact on bat habitat. That'll be mitigated by limiting tree removals to the October through March timeline, which is best practice for avoiding I think the mating seasons for those bats. Again, soil erosion and sedimentation control best practices we'll use to mitigate any impact the mussels in the waterways. And then finally, the floodplain. I mentioned how the floodplain was quite high. We're certainly going to be working in the floodplain. We do not anticipate a negative impact on the floodplain in terms of raising the floodplain. And actually some structures that are in the floodplain now are going to be located out of the floodplain by moving up the hill. So we see that as a a net positive impact for the work in the floodplain. Consumption of materials for the project. Certainly any construction project requires the consumption of materials. I think we'll be cognizant and mindful of trying to reduce or recycle construction waste during construction. That's typically done through construction specifications that are built around, trying to recycle and not just automatically send to landfill. There's a lot of specifications that have been developed as part of the green building practices that have kind of sprung up over the last 10 or 15 years. So we'll certainly implement those to be cognizant of material consumption. Human, social, and economic impacts. What the goal is would be to try to fund this with modest rate increases spread out over time, so that we don't have to do it one single large increase. Expenditures coming up.
Hey, Ernie,
Sure.
you started breaking up and then we lost you on voice.
Where did you lose me?
Just getting through the, you pretty much talked about the modest rate, second bullet.
So I mentioned not expanding beyond the existing boundaries of the wastewater treatment plant. Again, that's been a wastewater plant since 1965. No additional land area is going to be needed, so we won't be, sprawling out onto adjacent properties. We do see a beneficial temporary impact for construction jobs during the project. Projects of this size use lots and lots of all types of skilled labor, manufacturing. So it really has a positive impact on a local economy for projects of this size. And finally, the construction jobs will pay a Davis-Bacon Act wage rate, which is a requirement through the federal funding that is pushed down through the state. So that will be enforced, and we will make sure that all contractors on the project are in compliance. Finally, operational impacts. We got a great staff out there that work hard and take pride in a well-run and maintained plant. Most people I talk to that get the chance to go out there, comment on how clean and well-maintained it is. But the fact is, things just don't last forever. And so, these guys have done their best and will continue to do their best. But we also want to make sure they have the tools they need to continue to treat the sewage and make it clean before it goes into the river. We believe that this chosen alternative helps facilitate continued operation during the construction process, which is going to take 4 years plus. Certainly when we're done, the operational reliability will be improved, and won't have to deal with the failures, the yearly failures that we're encountering now. And then just the energy efficiency and reduced operating costs, that'll be a positive operational impact. So the schedule, it's going to be quite a long schedule. Like I said at the beginning, we're almost 3 years into just the planning of it right now. Kind of short term, after this meeting, the next kind of step is the public hearing. which is a more formal presentation of really the same kind of information, but we'll have a court reporter that'll take a verbatim transcript of the hearing, and then we turn that in to Eagle so they can see what types of comments we received. Public will have until July 1st to submit written comments. Any comments received by then will be included in the project plan, and we'll respond to the ones that we're able to. And we'll pull all that together by around July 15th with a planned presentation to the Board of Trustees and adoption of the plan on July 20th. And that's to hit an August 1st plan submittal, which is a requirement of Eagle. So then between that August 1 and spring of 2022, we'll have lots of design engineering to do and a bidding process to get a contractor selected. But the goal is to start the first phase in spring of 2022, start phase 2 in the spring of 2024, and wrap up both of those phases by the fall of 2026. And that gives us about a year to get up and running, get all the kinks worked out, and make sure we're hitting our new discharge limits with the tertiary treatment in the fall of 2027. So that's kind of a high-level overview of the project schedule. Certainly, there'll be lots of other steps and milestones, but those are the big ones that I wanted to point out. With that, I'd just like to thank you for joining us to learn more about this important project. I feel like I've been talking forever, so I'm going to be quiet and take any questions or open it up to the comments at this time. Does any of Rick or Gary Markstrom, does any of you guys want to cover anything I might have glossed over?
No, I think we covered quite a bit. The big important, probably the most important thing that you did mention, but I want to just kind of point out that we will be in full operation during this whole process. We cannot turn these flows off, and we cannot relax our treatment requirement. So we will be in full operation the entire process, and that was a big part of our selection of how we picked our option B and 9 criteria. It really makes full potential of the day-to-day operations and be able to maintain those.
Ernie, I have a question. You touched on the, the amount projected at this point in time for rate increases, to cover the cost of the state revolving loan fund, which is a below market interest rate, mostly subsidized by federal dollars, and then repayment schemes back to the state of Michigan that turns it over again. But do we know basically what the length of time, the duration of that loan will be, both for phase 1 and phase 2? Do we have like a clue as to what maybe the timeline may be? 20 years, 25 years?
Yes, we're right now planning around a 20-year loan period for each loan. It'd be 2 separate loans. Each one would be a 20-year period, so they'd be staggered a couple of years apart in terms of their maturation. They do offer a 30-year option, but that's not something we're exploring right now.
Okay. Maybe a follow-up question to that is what is the useful life expectancy of all the improvements once this project is completed?
I don't know, Brent or Gary, do you want to speak to that? I think it's a little bit, you look at things like electrical systems and pumps and process pieces, they're probably in the 20-year range. Mechanical things, but things like tanks and pipes and the pipes that connect the different processes, they're more in the 40 to 50-year range. So certainly some of this stuff wears out, in 20 years. But we've also had a long history of maintenance of making things last. I mean, we've got pieces of equipment at that plant right now from 72 that have been rebuilt multitudes of times and are still functioning. So I don't know if I can give a concise answer. Brett, do you have anything better to add?
Yeah, typically from a process equipment standpoint, the clarifiers, pumps, things like that, we look at, 25-year life expectancy on that. You start looking at structures such as, concrete tanks and things like that. That's more to a 50 to 60-year life expectancy. Piping systems are 30 to 40 year, but like Ernie said, majority of that stuff that's been on site has been operating for, 40 years at this point. So with a good maintenance program, like what it's being done out there at the plant now, it definitely increases your expectancy on your equipment and stuff and in the return on the capital cost.
As to be expected. Thank you for the answer to the question.
Any other questions?
Yeah, we do have a question from Diane here, Ernie.
Hi, you mentioned that you might be able to offset some of the cost increase to the residents by getting some grants. Are those being applied for now, or is that a real thing, or is that speculative?
No, we are in the process right now. We've been coordinating. We have a project manager that's been assigned to us from Eagle, and I forget when it was, back in May, we turned in kind of a business case analysis of, a lot of these numbers that I showed you on that chart about the percentage of energy that we could save over the other option. Well, we felt pretty good that shows what they call a categorical qualification of the project. And so with that, any cost, I think it was around potentially up to $6 million could be eligible for that program. Certainly we won't know until they go through their final rankings and we see what kind of funding is available. But from what I could tell in previous years, they've awarded grants that high or higher. So we do feel like it's a realistic possibility that, and it's not just, wishful thinking. So I guess stay tuned. I can't give you a hard answer, but, I think we've put our best case forward, and I think our selection gives us the best chance.
Okay, but at $6 million, we probably wouldn't see, it would be a negligible impact on the cost increase if it's only less than 10% of the entire project, right?
Yeah, I don't know how that would impact the monthly user, that $10 increase. We haven't run those numbers, but we certainly, I can tell you when it, if and when we are awarded some funding, we will be able to then put that into the formula, and we'll do our best to, mitigate those increases considering that loan forgiveness.
Thank you.
Thanks for the question.
Yeah, Ernie, I have another follow-up question. you had like a timeline there from when we apply for the state revolving loan fund application and all that, and when the construction starts. I know that in previous discussions, we're talking about sort of an extended design process, because it's a very complex project, anywhere from 12 to 18 months. But when do you, and Brian, you may want to weigh in on this, is when you think in ballpark we might expect that an RFP for a general contractor for this project, will be coming before the board and let.
So we would likely, I think right now we're looking at January or February of 2022. That would be my best guess now of having a bid package on the street to solicit bids. So, roughly the beginning of 2022 with the goal, that process takes a couple months to get through, to work from getting bids to getting a contractor selected and an agreement in place. So if we're going to start in April of 2022, we need, January, February timeline of 2022 is when we would have a bid package on the street. Did that address it, Dennis?
Yes, it does. Thank you, Ernie.
Yep. Any other questions?
Yep, Elaine has a question. Please don't forget to unmute your mic, Elaine. Oh, 1 second, you're still muted.
There we go. Can you hear me now?
Yes, ma'am, go ahead.
Just not real familiar with this. Didn't know what button I was pushing, but while I have you guys, I want to say it looks like you've been doing a great job. And nobody wants to see prices go up, but no one wants their sewage system to fail either. So I'm really excited about what you're doing. And thumbs up. I meant to hit thumbs up, and I ended up asking to speak with you. Well, here you go. Thumbs up. Thanks a lot.
Thank you, Elaine.
Ernie, Renee has something to say.
Hello, I'm just giving a thumbs up to the project as well. I like that the gravity, incorporating the gravity type concept and saving on electricity sounds wonderful, as well as getting some of that equipment out of the floodplain. I think it's a great project. I support it as well.
Thank you,
Thank you.
Renee. Well, if no one has anything else, we can adjourn for tonight. I guess I'd just remind you, if you'd like to take part in the next step, that'd be the June 24th public hearing. If you are in support of the project, or if you're not, either way, you're free to send us your your written comments. Best way to do that's at the project email that we set up, which is wwtpproject@deltami.gov. Those come to all of us, and that allows us to track those comments and make sure we take them into account. So whether we'll certainly take positive comments. So if you want to follow up your statements, by all means. But oh, Andrea, did you have something?
I did. Thank you. Appreciate all the information that you're sharing this evening. Just wanted to ask if it might be possible to make it easy to provide a direct link on the website for the next meeting. I know we had the information, but you kind of had to have it written down and type it in, and just to make it easier for everyone to access the Zoom meeting, that I think that might be helpful with a direct link.
Certainly
Sure.
can.
Thank you.
If no one has anything else, then we'll adjourn. And again, I thank you for your time tonight. And everyone take care and stay safe and healthy.
Thank you, Ernie, and thank everybody for their support.